Hello, welcome back. Mr. Wakefield here, looking at section 10.1 now. 10.1 is the section that has the second of the four different methods that we're going to learn for solving a quadratic equation. Again, let's review what a quadratic equation is so we don't get it confused with some other equations that we're going to learn about, including the linear equations that we already learned about back in sections 3.1 through 3.3. Quadratic equations are the ones where if you've got a polynomial on both sides of the equation, here you got a single-term polynomial, here you got two-term polynomial because of the minus in between. Here you just got a single term on each side. But both sides of the equations are polynomials. And when you have a polynomial on both sides and the highest exponent that's attached to a variable is 2, such as a squared or x squared, notice you don't see x to the third power or x to the fourth power. If the highest exponent attached to a variable is to the second power, a to the second, x to the second, y to the second, for example, okay, then you have your a quadratic equation in that case. So what we're going to be looking at here is our second method. It's called the square root property. Now, why can't we just use the other method all the time, the one that we learned at the end of the last packet, section 7.5? It's because it involves factoring. But we know from our factoring chapter that we did back in chapter 7 that not everything factors. Okay, sometimes you got a polynomial that's prime and it doesn't factor. And so that's not the only reason, but that's one of the big reasons why the factoring method is not something you always want to use. Okay, now in this particular section, we are required, it's not a choice, we are required to use the square root property on the problems in this section, and there will be at least one question on the upcoming exam where you are definitely required to use the square root property. So you can't ignore this property, and you're not going to want to. I think you'll see after you do this worksheet that it is a good choice to use in a lot of situations anyway. Okay, so anyway, let's go ahead and move on and start talking about it here. What is saying here when you have the square root property? And I want to make this really clear here. Notice how x squared is on one side of the equal sign, but it's only x squared. Okay, it is not 3x squared. It is not 5x squared. It is not even negative x squared. Okay, it is literally just the x and the 2, and that's it. Okay, if you've just got x squared only by itself and nothing else on one side of that equal sign, as long as there is, and the k represents a constant right here. Remember, a constant is just basically a normal number. There's no variable there at all. Okay, so if you've got, for example, x squared equal to 23, that would qualify. If you've got, and it doesn't have to be x, it could be any letter, but if you've got a letter and then the 2, and that's all you have on one side of the equal sign, and then you've got a constant number, no variable on the other side, then that also qualifies. Okay, again, it could be any letter. All right, so if you've got a letter being squared and that's all on one side of the equal sign, and then you have just a constant, no variable on the other, that's where we use what we call the square root property. What is that? Well, it's saying to do two different square roots here, two different radicals on the next step. Let me show you how that works. Okay, see how they're taking the square root of k, though, which is that constant number? So in this case, you're going to take what? You're going to take the square root of 100, okay, equal to what now? See how the x squared changes into x? So what happens is when you do the square roots, the radicals, the exponent basically disappears simultaneously on the next step. So the y squared becomes a y. And then same thing here, y squared becomes a y. See how you write down the variable twice here with no exponent anymore? Okay, and so I did that, y and y. And then I do the two square roots, okay? The square root with no negative in front of it, okay? Like we have here, no negative in front of that. So I did that here. And then I do the square root again with a negative in front of it. And those are the two different answers. Notice that the variable is by itself already. That's great, all right? Remember, when we solve a one variable equation, that's our goal, is to get the variable alone, by itself. All right, we did it. we have two different answers, but that's not a surprise. We saw that in the last section, 7.5 as well. Okay, that happens on a lot of these problems. Not all of them, but a lot of them. And so the only thing left to do is that they want us to, in the final answer, I know it doesn't say this in the directions, but in a lot of cases they will say this. If there is, in fact, I'll go ahead and write it down here because we're going to do it in this worksheet here. Any radicals in the final answer, go ahead and write this down just so you know why I did this next step I'm about to do. Any radicals in the final answer must be what? They must be simplified. Okay, we learned how to simplify radicals back in chapter 9. Okay, but in this particular case, when they ask you to simplify a radical, and we've done this before, if they ask you to simplify a radical, but the number underneath the square root is a perfect square number, you know, like 4 or 9 or 16 or one of those types of numbers. And 100 is one of those numbers. It's one of those numbers that you know the square root of it. Okay? When that happens, then you just evaluate the square root. You actually figure out what it's equal to. You don't have to like break it down into two separate radicals like you do in the other radical problems that you have to simplify where you don't have a perfect square number underneath it. No, this is one of those ones where you can just figure it out. It's 10, right? Which would then make this what? It would make this negative 1 times 10, okay? Because remember, when you have a negative and then a radical, and that's all you have on that side of the equal sign, that means negative 1 times the radical, okay? Which means negative 1 times what? It means negative 1 times 10 because you compute the radical before you multiply. We learned about that before, okay, back in chapter 9. So this would end up being negative 1 times 10, which is negative 10. You don't have to write down all this stuff here. We've learned about that already, so I'll let you just write down negative 10 as long as you're sure that it's negative 10. That's fine. So we did it. We got y by itself. We figured out what the radicals were equal to. We simplified them. One last thing that you can do, you don't have to do this, but I would highly recommend that you start doing it now because we're going to need to get used to it later, is that if you get two answers, you guys, and again, you could circle this. This is fine. You can stop right here. But I highly recommend that you do this. If you get two answers, if and only if you get two answers where they're the same answer except for one of them has a positive and one of them has a negative in the same place. See how there's an invisible positive? Anytime you have a number with no negative in front of it, that means there's an invisible positive in front of it. Okay, that's positive 10, isn't it? So you got an invisible positive in front of the 10 and you've got a negative in front of this 10. So the answers are the same, except for one's got a positive in front of the 10 and the other one's got a negative in front of that same 10. So you've got a positive and a negative in the same exact place in front of the 10. The rest of the answer is the same, 10 and 10. Okay, when that happens, and I'll talk about this more here, okay, as we get, don't worry, we'll get used to it here. But when that happens, you don't change it, but you condense the answer down into a single statement instead of having it separate like this, plus or minus 10. Whenever you see the plus or minus, it's saying automatically that you've got two different answers in that same spot where you see the plus and minus symbol, okay? One of them with a positive there and one of them with a negative there. So anytime you see that plus minus symbol, that means two different answers, okay? And the two answers are exactly the same, except for one has a positive right there and one has a negative right there. But everything else is the same. Okay, so therefore this is positive and negative 10 when you read that. Okay, we also call it plus or minus 10. Let's try that again. Again, you have the variable being squared all by itself. It's not 3x squared, it's not 5x squared, it's just x squared. And then on the other side, you have no variable. Remember, if this had said 23x over here, and we saw something like that in the last section, didn't we? See how we had y squared by itself right here, but we did not have a constant on the other side? We had a variable over there. You cannot do the square root property on this because of that variable right there. Okay? It has to be a constant number here. So, because it's in the correct form, as we learned up here, we then on the next step, we bring down the x twice, just like I did have right here, x and x, x and x. The exponent goes away. And then on that same step where the exponent goes away, what do? We write down two radicals, two square root radicals, okay? And you put a negative in front of the second one. Just like you have here, the radicals and then a negative in front of the second one. And there you go. We got the x by itself. So we did it. We solved for x. Last two questions we got to ask ourselves, though, is can you simplify this radical like they asked us to? No, 23 doesn't simplify. You can't factor a 4 out of it. You can't factor a 9 out of it. 16 doesn't work either. You can't simplify that. So the last thing that we should do, again, you could circle this if you want, but I want you to get used to this whole plus or minus symbol. Okay, remember that these two answers are exactly the same, except for one has an invisible positive in front there, and one has an invisible negative in front here. I'm sorry, that one's not invisible. Excuse me. This one, you can see the negative, right? So you got a positive in front of this radical. You got a negative in front of that one. So if you want to condense it down to one answer, then you say plus or minus square root of 23. You might be wondering, hey, wait a second. I don't have to put the plus in front of this one right here. So does that mean that the plus can be left out down here as well? Okay, can the plus be invisible here? No, it can't be, because if you don't put the plus here, it's going to look like you're just saying negative square root of 23. And we know that there's two answers here. Not just the one with the negative, but the one with the positive in front as well. So when you condense it down, you do need to include that plus. Even though in this case, when it's just positive only over here on the left of the answer, you don't need to put the plus there. You know, anytime you have just a single number, in this case just a radical on one side of the equal sign, if it's positive in the front, you don't need to write the plus. You can, but you don't need to. But when you condense it down like this, you got to put that plus there. Otherwise, it's going to look like it's just negative only. All right. And that would be ignoring the positive answer over here on the left. All right. So moving on to this next part here, notice that we have y squared. Okay. We have a variable being squared like we do up here. But the difference is that it's not by itself. Okay, but they told us to use the square root property. How can we use the square root property if this is not by itself? Meaning the y squared. All right, if I could just get this thing by itself here, I could then use the property. Can I do that? Am I allowed to do that? Yeah, you are, as long as you're able to do it with the mathematical rules that we've learned. Okay, but this is the thing that I highlighted here in this box. That's the thing you want to get by itself. All right. As long as there's a constant number on the other side, after you get the variable squared by itself, then you can use the property. Okay, so you might be wondering, well, how do I do that? Do I subtract the 11 over, or do I divide the 11 over? Okay, do I divide out the 11? The best way to know which step to do is imagine that the thing that you're trying to get by itself, in this case, it's not just the y, but it's the y squared right now. Imagine that that's a variable. I'll call it m, okay? Don't use the same letter. That can be confusing. But I'll call it m. So instead of the box plus 11 equal to 9, since I'm trying to get the box by itself, I'm going to pretend like the box is a letter. And now I'm going to ask myself, how do I get the m by itself here? Well, suddenly, and we're just pretending here off to the side, but suddenly this equation became a linear equation because it's just m to the first power. It's not m to the second. Okay, we learned in chapter 3 that when you have a linear equation, okay, no m squareds or m to the third, just m, we learned that in that case you have to put the constant numbers, the constant terms that don't have the variable in it, on the opposite side of where the variable is. And we do that by adding or subtracting them over. So we need to get the variable term by itself by moving the 9 and the 11 over to the other side, like this. That cancels the 11. And now we got m equal to negative 2, right? Do I need to divide out? Do I need to do that last step that we normally do for a linear equation? No, I do not, because m is already by itself. So you don't need to, if it had been 2m, then you'd divide by 2. Or if it had been 3m, you'd divide by 3, right? That's the steps of the linear equations. Okay. My point here is that if you pretend like that thing that you're trying to get by itself is a variable, and then you figure out how to get that variable by itself, the way in which you get the box by itself is exactly the same steps. Okay? So just like I subtracted the 11 over, I'm going to subtract the 11 over here, and I promise you that will work, and that's perfectly valid. It's a perfectly valid method to do. Okay? The 11s cancel just like they did over here. And so we end up with y squared by itself equal to negative 2. Just like we had m by itself equal to negative 2. All right? So the y squared behaves like a normal variable would. So now we got what? Now we've got the variable squared by itself, y squared, and we have a constant negative 2 on the other side. So we jump to that next step. Okay. So what do? We take the 2, we write down the y twice here, y and y, and then we write down the radical twice, one of them with a negative in front. But what do I put inside the radical, though? The number that's on the other side of the y squared, right? But you got to get the y squared by itself first before you can do this. So don't put the 9 inside the radical. You can't use this property up here at the top of the page. All right, you can't use that unless the variable scores by itself first. So don't put the 9 in there, put the negative 2 in there. Okay, we got a problem here, though, that's different than the previous two problems. We got an issue here. The issue here is that we have a negative number underneath the square root. We learned back in Chapter 9 that when you have a negative number underneath the square root, the answer doesn't exist. There's no real number answer for that. So if you get two radicals here, you guys, two square root radicals, which this is the square root property, so we're only going to get square roots. We're not going to get cube roots. Okay, if you get a square root radical and both of them have a negative number underneath, we say no solution. Why? It's because those two radicals do not exist. Okay, they do not equal anything. They're not equal to a real number. Because they have a negative number underneath it. Okay, so that's how you'd handle that situation. We didn't do that over here, though, because the radicals had what? They had positive numbers underneath it, 123 over here. But negative 2, that's different. Okay? So no solution if both of your radicals have a negative number underneath it, okay, in the square root property, because you can't have the square root of a negative number. Let's try that again now in problems D and E. Notice in D and E, problem D, z squared is not by itself. In problem E, the n squared is not by itself, but in order to use the square root property like the problem asks us to do, okay, you have to what? You have to get those things by themselves. Okay? And the method that I'm going to use, again, you don't have to do this as long as you're sure that you know the correct steps to get the z squared and the n squared by itself. But if there's any uncertainty at all, do the same thing we did in the last problem. Pretend like the box there, and again, we're not trying to get 3z squared by itself ultimately. We're trying to get z squared by itself. We can't have a number or even a negative sign in front of the z squared when we get it by itself. It's just got to be z squared. It's got to be just n squared here. Okay, so how do we do that? We pretend like that box right there is a variable. So for example, I'll use the letter m again. Instead of 3z squared minus 7, I'm going to say 3m minus 7 equal to 17. And then you're going to do the same thing we did up here. This is now a linear equation because it's just m, it's not m squared. All right, so what you do is you need to get the 7 and the 17 on the same side before you divide out the 3 there. Okay. You got to get the single variable term and a single constant term right here before you divide out. Okay. like this. All right. And then that cancels, and now we get m equal to 8, right? Like that. The same steps are going to be used in this problem. Okay, so what did we do here? We added the 7 over, and then we divided the 3. Same exact thing here. This is how you can be certain that you're doing the right steps. Just do the same steps you did here. So the 7's cancel, just like they did over here. Okay, and we get 3z squared equal to 24, just like we got 3m equal to 24. Z squared and m are playing the same role here. They're doing the same thing, okay, because we're trying to get them both by themselves. All right, so then you divide out the 3. The 3's cancel, and you get z squared equal to 8, just like we got m equal to 8. Again, z squared and m are playing the same role here, and they're both equal to 8 as a result. So what do we got here? We've got the variable squared by itself. We've got no variable on the other side, just a constant number, and so that means that we can do the square root property, but not until you have this situation. Variable squared, and then no variable on the other side. Okay, so we know from the top of the page that we're supposed to do what when we get that situation? We're supposed to write down the variable twice. In this case, it's z. And then we write down 2 radicals here, one with the negative in front of it. Put the negative right there. The other one doesn't have a negative in front of it. And then you put the constant number underneath that, 8. Again, not 17, not 24, but it's after you get the variable squared by itself. It's that number that you put underneath there. So we did it. We got z by itself. But there's 2 more things that we need to do. One of them is optional, like I said, but it's highly recommended. We'll get to that in a minute. But first of all, we need to simplify these radicals like we talked about. The radical 8 can be simplified. We can factor a 4 out of that, can't we? I'll just do that off to the side here. And so that gives me, square root of 4 gives me the 2, and then the second radical, as usual, stays the same there. So this becomes what now? This becomes 2 rad 2 and negative 2 rad 2. Okay, now again, you could circle your answer right now. Okay, you can circle this. But what's that last step that we could do? Like we said, if you've got 2 answers that are exactly the same, except for you have a positive, in this case an invisible positive in front of the 2 here, and then you have a negative in that same exact spot right in front of the 2, but everything else is the same other than the positive and then a negative in the same spot, that means what? That means that we can say plus or minus in that same spot. Okay, that way when somebody reads this, okay, they'll know that there's 2 answers, one that has a positive in this spot and one that has a negative in that same spot right in front of the 2. Okay, let's do that one more time here, and then I'll let you guys try some of these. So on problem E, again, you can think of n squared because we need to get that by itself. You need to get the variable squared by itself when we're asked to use a square root property, right? So we need to think, okay, how am I going to get that thing that I boxed in right here by itself? We're going to pretend like that's a variable again. Again, this is just you don't have to write down this thing off to the side here with the m if you already know what the steps are. But if you're not sure, I highly recommend that you do these steps so that you will be sure that you're doing the right steps when you come back over here to the real problem that we're doing. Okay. So what do we got to do here? We need to move over the 17, like with any linear equation. You got to move the terms that don't have the variable in it to the opposite side of where the variable term is. So I need to move that 17 over. Get 9m equal to 1. And then once I got a single variable term and a single constant term, I then do the division step. And I got m equal to 1/9. Okay. Same thing over here in the real problem. The steps are going to be exactly the same. All right, we are going to subtract the 17 over. It cancels just like it did in the pretend problem over here. And we get 9n squared equal to 1, just like we got 9m equal to 1. And then we divide out by the 9, just like we did over here. The 9s will cancel, just like they did over here. And we get n squared equal to 1/9, just like we got m equal to 1/9. So now I have the variable squared by itself, no variable on the other side. What do? We then take, as always, we take the variable without the exponent now. We bring it down here twice. There's going to be two answers, like we said. And then we write down the radical twice, one with a negative in front of it, like that. And then put the number that's on the other side of the n squared inside of the radical. So again, we got the variable by itself. Great. Okay, we just now need to simplify the radicals, and then we can do that thing where we do the plus or minus. Okay, so to simplify this radical here, you actually don't need to think of it as simplifying, because again, just like the problem up here in problem A, if you have a perfect square underneath the radical, then you just figure out what the square root's equal to. Same thing here. As we learned back in 9.1, just to refresh your memory, if you've got, for example, 36 over 49, since 36 and 49 are both square roots, since they're both perfect square numbers, all right, then that means that you can figure out what that radical is too. You don't need to break it up into two radicals there. It's just 6 and 7. 6 comes from the 36 and 7 comes from the 49. It's the same thing here. Okay. 1 gives you 1 and 9 gives you 3, right? So if both of the top and bottom of the radical, of the inside of the radical, is a perfect square, then you can figure out the square root. All right. You don't need to break it up into two radicals and all that other stuff. So we get what here? We get 1/3 and negative 1/3. Just like we got 10 and negative 10 on this one when we figured out the square roots. Okay. Final answer here then would be what? It would be n is equal to plus or minus 1/3, because the two answers are exactly the same except for you have a positive and negative in front of the 1/3. Okay. All right. You'll see here in the next couple problems, we don't have a variable being squared. We've got an entire bracket being squared. That's a whole different type of situation. Okay, so what I'd like you to do right now is to do problems 1 and 2 here, and they don't have that bracket. Okay, and also please do 5 and 6 on the second page. 5 and 6, you can see those don't have the bracket either. So do those 4 problems. Okay, and then after you do that, then we'll talk about how to handle that bracket thing where you have the bracket being squared. Okay, so hit the play button after you're done, and we'll take a look at those answers to 1, 2, 5, and 6. Don't do the other ones yet. All right, let's take a look at number 1 here. We've got the variable squared by itself. We've got no variable on the other side, so we can jump right into that double square root thing that we've been doing all along here in this section. Okay, write down the 2 square roots, a negative in front of the second one. The x is now by itself. All right, but we still have 2 more things to do. We simplify the radical, and if the radical has a perfect square number underneath it, like 81 is, then you just figure out what it's equal to. It's just 9, so we end up with 9 and negative 9. Okay, and then finally, how do we condense our answer into one statement? With 9 and negative 9, we say what? We say plus or minus 9, don't we? Okay, just like we did in problem A and in problem E. All right, and pretty much all the problems, but those are the ones where the radicals disappeared at the end because we were able to figure out what the square root was equal to. Okay, but yeah, we've been doing plus or minus on all of them. Next one here, y squared by itself, no variable on the other side, so we can jump right into the double square root thing. All right, the 2 radicals, the y is now by itself, no exponent anymore. And so we just need to simplify the radical. Since that is a perfect square number, 144 is, that means that it's what? It's equal to 12, and then that means that this one's negative 12. Okay, because remember, this is -1 times whatever the radical is equal to when it's written like this, like we saw in section 9.1. Okay, just a reminder there, just to give you a visual of that. Remember, again, if you have a negative in front of the radical, and just those two things, the negative and the square root, you figure out what the radical is equal to first, and then you multiply by the -1 in front of it. That's why we're getting -12 right here. Okay. And then we condense it down to what? Plus or minus 12, just like we've been doing. Okay, let's move to the second page here. Okay. Number 5. There it is right there. Since the x squared is not by itself, but the directions asked us to use a square root property, that means I'm going to pretend like the x squared is a variable. I'm then going to get it by itself using the normal linear equation steps. Okay, because this is a linear equation now. The pretend equation is a linear equation. We move over to the 36. That gets m by itself. And so in the same way here, we move the 36 over in the real problem. Okay, this is m equal, I didn't write that down, but this is m equal to -36 if you want to see that. Okay, and so in the same way, this is x squared equal to -36. But what's going to happen when I now do the square root property? I'm going to get two radicals that have a what? That have a negative underneath. And no, the two negatives don't cancel. You're not allowed to do that. Okay. Remember, when you figure this out, or at least attempt to figure it out, you've got to figure out what the radical is equal to first before you can even deal with the negative in front. You're supposed to figure out what the radical is equal to first before you multiply by the -1 that's in front of it there. Okay, just like I said in the last problem. Okay, but the problem with doing that is that the radical doesn't even have an answer because it has a negative number underneath the square root. Okay, so don't make the two negatives into a positive. That doesn't work that way here. Okay, we're not multiplying -1 times -36. You got to figure out the radical before you can multiply. But the radical doesn't have an answer. So what does this mean? Just like we saw in problem C on the first page, it means that those are not real numbers and therefore we have no solution. No solution. Okay? Just like in problem C, same thing. Lastly here in number 6, 2x squared plus 9, we need to get the x squared by itself. So that's just like getting the m by itself up here. How would I get the m by itself right there? Okay, actually I didn't write it down here, but I'll go ahead and write it down off to the side. Here it is right here. So you're going to subtract the 9 over, right? To get the m term by itself. Again, this is for linear equations, which is what these pretend equations are. You then divide out the 2 to get the m by itself. So in the same way, we do the same steps over here in the real problem. You subtract the 9, the 9's cancel, just like they do here. And then you divide out the 2, and just like we got m equal to 27, I got x squared equal to 27. I then do the double square root. Okay, and now x is by itself. What does that mean when x is by itself in a square root property problem? It means that we simplify the radicals and then we do that plus or minus thing. I simplified the radical over here. That's where I got the 3 square root of 3 thing on both of these. And then I did the plus or minus. Okay? And so that is what you do when you have, first of all, that's what you do when you have a problem that says to use a square root property. Okay, and you have just the variable being squared in the problem. It doesn't have to be by itself like we see here in some of these problems, including this one. If it's not by itself, you get it by itself. Then you do the double square root thing. Okay, but that's just when the variable is being squared. What happens, as I was hinting at before I stopped the video a moment ago, what happens if we have instead of the variable by itself, or pardon me, the variable being squared, we have a bracket being squared. Remember, when you have a bracket, you guys, right next to the exponent, it's the entire bracket that's being squared. Okay, not just the 7, not just the -7, but the entire bracket. So the entire bracket is being squared. What I want to make clear to you is that when you have a bracket being squared here, you can also use this property as long as the bracket squared is by itself. You can't have any terms over here on the left of the bracket. You can't have any terms over here on the right of the bracket after the exponent. No. It's got to be just the bracket and the 2 by itself on one side of the equal sign. And then on the other side, it's got to be what? It's got to be a constant again. It can't have any variables over there. But if you do have these things, if you've got the bracket and the 2 by itself, and you've got no variable over here, you can then do the same property. The only difference is that instead of having just the variable here on the next step, you have the bracket here by itself with no exponent. So once again, the exponent is going to disappear, okay, but the bracket will now be by itself, okay, and you'll still have the 2 square roots. That stays the same. That won't change. Okay, you'll still have the 2 square roots with the negative in front of the second one. But now the bracket is going to be by itself. Let's see how that works. So if you've got a bracket squared equal to a constant, that means that on the next step, you're going to write down the bracket. And when I say the bracket, you can just write down the inside of the bracket. You don't need to write the bracket anymore, because whenever you have just a bracket only on one side of an equal sign with nothing outside of it, and the 2 is gone now, right? Just like it was before, the exponent's going to go away on this step. What happens is that if you've got just a bracket by itself, you don't need to write the bracket. You can just write the inside of it. So you can just write down 2w minus 7 twice. Just like we wrote down, just like we went from n squared to n, okay, where the exponent disappeared, same thing here. The exponent disappears, we just have the bracket. And we write down the bracket twice. But you don't need to write the bracket because there's nothing outside the bracket. Then we do the double square root thing. Again, that's still the same as it was before. Okay, so square root of 63, negative square root of 63. Now here's the problem. Okay, we need to get the w by itself. Okay, whenever we got rid of the exponent in the previous problems, the variable was already by itself. Okay, and we were almost done. Now it's not, okay? But this is not as hard as it looks, okay? Give me a chance to explain it here, okay? I know that this looks weird because of the square root and the square root over here as well, okay? But because that square root, you guys, does not have a variable in it, there's no variable at all over here. It's just the square root of 63. I want to make it clear to you guys that this is no different than if you had something like this. You don't have to write this down. Just look at this here. Instead of having the square root there, it'd be no different than if you had like just a normal constant number there. Because if there's no variable here on this side of the equal sign, it's no different than an 11 as far as the steps that you do. Okay? Remember, this is a linear equation here because it's just w. It's not w to the second or w to the third. So because of that, we do the same thing we always do. We move the 2 terms that don't have the variable in it to the opposite side of where the w term is. Okay, I know this is just I know this isn't the real problem, but my point is that whatever we do over here in this problem, we're going to do the same thing over here. So let me just show this to you real quick. All right. So we would move over the 11 and the 7 together, right? And then we would divide out the 2, wouldn't we? All right. Now there is a minor issue here though, okay, that you need to be aware of. When we move over the 7 with the square root of 63, we can't combine the 7 and the square root of 63 like we were able to combine the 11 and the 7, because these were like terms. And so I was able to combine them and make them equal to 18. Okay, when I move over the 7, and we still do it the same way we did over here, same way, but when we move it over, here's the thing. If you have a radical term and a regular term that's not a radical term being either added together or subtracted, in this case is being added, okay, you can't combine these. Okay, it's just like in the last section that we did here. Okay, look at how we moved over the 81 with the 4a squared. Those aren't like terms, are they? Did I combine them? No. Okay, I was trying to subtract two things that were not like terms, so I couldn't combine them. I had to keep that minus sign separating the two terms into two separate terms there. I couldn't combine them into one term. Okay, so if they're not like terms, then you're either subtracting them, or if you're adding them like we are here, you have to have a plus or minus in between them after you bring them down to the next line. They can't get combined into one term. So that plus or minus has to still be between. Okay, so whenever you have a regular term being added or subtracted to a radical term, remember that, you guys, you can't combine them. You've got to have a plus or minus still separating them. All right, so this is what it's going to look like. 2w, the 7's canceled over here. And then normally we would write down square root of 63 plus 7. But usually when you have a regular term and a radical term being added or subtracted, we usually put the regular term in front. Okay, and how do we write that? Well, remember, it's just like when you have, if you have like x plus 7 over here. Okay, if you had x plus 7, you could either write x plus 7. These are not like terms, so we got to keep the plus in between it. Or you could write 7 plus x, right? As long as the sign in front of each term is still the same, positive and positive, is still positive and positive, the same two signs, positive and positive. And also, you have to have either a plus or minus separating it still, since they're not like terms. So as long as the signs are the same in front of each term, and as long as you still have a plus or minus separating them, you're allowed to reverse the order of two terms that are being added or subtracted together. Okay, these are being added, so I can reverse them as long as I still have the same signs in front of each term. Positive and positive is in front of each term here, and that's still true. And I still have a plus or minus in between it. In this case, it's positive between it because you got to have a positive in front of the radical, since it's positive in front of it. Okay, if this had been negative in front of the radical, then you put minus right here, for example. I'll do this problem over here in just a moment. But what did we do, you guys, after we moved over the 7 in this pretend problem here? We then what? We then had to divide out the 2. Same thing here. Okay, so even though you have two terms over here, okay, even though you got two terms over there, and they weren't able to be combined, that's okay, because as long as you get the variable term by itself and the variable's not on the other side, and you've moved all the other terms over to the other side that don't have the variable in it, like we did with the 7 and the radical, you're allowed to divide out. As long as you got a single variable term here and there's no variables on the other side, you can divide out. So I know that we normally have like a single term on each side when we divide out, and I've talked about that, I know, many times. Okay, I know you've heard me say that a lot. But it's okay to still divide out as long as you have a single variable term on one side and no variable on the other side. So even if you have more than one term over here, as long as there's no variable over here, you can still do that division step. And then the w is by itself. So what do we got here? We got w equal to 7 plus rad 63 over 2. I'll simplify that radical in just a moment. Let me show you what the other answer is over here. We do the same exact steps here, you guys. The difference, as I just mentioned, is that when you have a negative term here, when you reverse the order, and again, remember, these are not like terms, so you can't combine them. You still got to have a plus or minus in between them when you bring it down here. But if you want to put the 7 in front, like I told you that we normally do, a regular term usually gets put in front of a radical term, then you can do that as long as you still have the same sign in front of each term, positive in front of 7, negative in front of the radical, and as long as you still have a plus or minus in between it. Okay? And I got to have a minus in between it, because in between the terms, because the second term has to have a negative in front of it, like it says up here. The radical has to have a negative in front of it. And then we do the division step. Like I said, you can do that as long as the variable term's by itself and the variable's not on the other side. And we get this right here. Okay, finally we got the variable by itself, right? What's those last two things that we do in these problems after we get the variable by itself? We first of all simplify the radical. Okay, what is square root of 63 when I simplify that? That is square root of 9 and square root of 7, which becomes 3 square root of 7. And so this becomes what? This becomes 7 plus 3 square root of 7 over 2. 7 minus 3 square root of 7 over 2. Okay. And I'm going to go ahead and do the plus or minus thing all in one step here. Actually, you know what? I won't do that. I don't want to go too fast here since this is the first time we've seen one of these. So it's going to be 7 plus, and you can skip that to the last step here if you want. You're eventually going to get used to this, and you'll be able to do that without too much trouble, I think. But this is what it looks like. Okay. So again, you can circle this answer if you want. You don't need to do the plus or minus, although, like I said, it's highly recommended. Okay. So what's the other way of writing it? With the condensed version of it. W. Now notice the two answers are exactly the same, aren't they? Okay. They both have the 7, the 3 rad 7, and the 2, right? The only difference is that you have a plus in the middle of the top here and a minus in that same exact spot. As long as the two answers are exactly the same, except for you have a plus in one spot and a minus in the same exact spot, okay, in the other answer, you can then condense it down into one answer like this. And that's how we normally write it. Don't worry, we'll see more of these here. Okay, I know there's a lot going on there in the last part of the problem. Let's try that again here in problem letter G here. Notice in problem letter G, we have a bracket being squared here, but it's not by itself. Same thing that we talked about earlier. Okay, if you've got either a variable being squared or a bracket being squared, if they are not by themselves and the directions tell you to do the square root property, you need to get either the variable squared or the bracket squared by itself first. Okay? How do we do that? We pretend like the bracket being squared, and that includes the square just like it did here with the variable being squared. That thing you're trying to get by itself, you want to pretend like that's a variable. That includes the 2 here. Okay, so this is not m squared, all right? This whole thing is just m, because that's what you need to get by itself, the bracket squared. So this is m minus 2 equal to 10. How would I solve m minus 2 equal to 10, you guys? Wouldn't I just move the 2 over with the 10? Like that? Like, there it is. Like this right here. And now I get m equal to 12. So in the same way, if you've got a bracket being squared and it is, and you're using the square root property, you need to move that over. Like this. And now, just like the m is equal to 12, the bracket squared, that whole thing that we needed to get by itself, the bracket squared, that is now equal to 12. Okay. So whether you got a variable squared or a bracket being squared, if you're asked to do the square root property, okay, get it by itself if it's not already like it was in the last problem. Okay, get it by itself doing that M technique that I've been showing you here. Okay. By the way, some of you might be wondering, In the previous equations that we did, I told you that if you started the problem with some parentheses, that you got rid of them first. This is the one exception to that. Okay, if you're doing the factoring method with quadratic equations, you get rid of your parentheses first. If you're doing linear equations with parentheses, you get rid of the parentheses first. But when you're doing the square root property and you have parentheses, okay, but the parentheses are such that the parentheses are being squared and they ask you to do the square root property. In that case, do not get rid of the parentheses first by multiplying them out like we did in the previous equations that we did. What you need to do is you need to get the parentheses squared by itself first, then you do the double square root thing. Okay, so don't multiply them out like we did in the previous sections, is what I'm saying. Okay. That's just with the square root property. And we'll see some other situations later where we don't get rid of parentheses right away either. But when you solve quadratic equations by factoring, okay, that method or the linear method, when we solve linear equations in Chapter 3, yes, you do get rid of the parentheses first. No doubt about it. Okay, so I just wanted to make sure that we knew about that here. What do we do when we get the bracket squared by itself with no variable on the other side? We write down the inside of the parenthesis. You don't need to write down the entire parenthesis brackets itself. Just like I said in the last problem, you can just write down the inside of the parenthesis in the next step twice, just like I did with 2w minus 7 twice here. And then I write down the double square root. Square root of 12, negative square root of 12. Oh, but hey, the x is not by itself, right? But again, that radical is just like a normal constant number, all right? Because there's no variable over there on that side of the equal sign. So again, you don't have to write this down, but this is no different than if you had 5x plus 8 equal to, say, 3. 3 doesn't have a variable just like the radical doesn't. So we do the same steps. We move the 8 over, and then you divide by the 5 after that, right? You move the 8 over, you divide by the 5. I don't need to finish up this problem because it's just a pretend problem anyway. I just want you to see, I'll go and write down the division step here. I just want you to see what the steps look like. But the way in which it comes out is going to be a little bit different, but the steps are still the same though. So just like in this pretend problem here, we subtract over the 8. Now remember, when we subtract over the 8, we, just like in the last problem, because you have a radical term being subtracted with a regular term, do not combine them. Make sure there's a plus or minus still in between the two terms, separating them. So since the 8 is negative in front of it, and since the radical is positive in front of it, you put negative 8, and then you got to have a plus or minus in between. So I need to put a plus in front of that radical since the radical is positive in front of the radical up here. Okay, then we divide out the 5. And we got x by itself. Remember, do not, and I know you can't cancel anything here, but don't even try to cancel anything between the top and bottom here because you got two terms up here. Okay, so unless you want to factor first, remember in chapter 8, we learned with fractions, if you've got more than one term on either the top or bottom, you got to factor first and identify your factors before you can cancel. And I'm not going to ask you guys to factor when you have radicals. Okay, so if you got two terms on the top and one of them is a radical term, I'm not going to ask you to factor that. So you're not going to be required to cancel in a situation like this where you've got two terms separated by a plus or minus on the top. Okay, so don't do it, please, all right? Usually it would be wrong, if not always, all right? Because of the fact that there's two terms there. All right? So I'll go ahead and simplify that radical in just a moment there. I just want to make sure you don't do something you're not supposed to do there with the canceling. Okay. Same thing here. We need to move the 8 over. And then because these both are negative in front, when I reverse it around, you got minus 8 minus radical 12. Divide out the 5. The 5's cancel, just like they do over here. And you get what? An answer that looks almost the same as the other one, right? There we go. And so once again, we've got an x by itself. What's the last two things we do in a square root property problem after we get the x by itself? We simplify the radical. If you simplify the radical 12, you get 4 and 3, which gives you 2 rad 3 right there. So this is going to be what? It's going to be negative 8 plus 2 rad 3. I'm just replacing the rad 12 with its simplified equivalent. Okay, 2 rad 3. So let me get that in there. There we go. And then the last thing we do after we simplify the radical is we condense our answer, right? So notice again, just like in the last problem, the two answers look identical except for you got something different in the middle of the numerator, don't you? A plus here and a minus here. So what can we do? We can say negative 8 plus or minus 2 rad 3 all over 5. Okay. Make sure that fraction bar extends all the way across, because when you're dividing out the 5 way up here, you're dividing the entire thing by 5. So make sure that bar goes all the way across. Okay. What we have here left over in our current section 10.1 is on the second page, we have still what? 3, 4, and 7. Notice in 3 and 4, we already have the bracket squared by itself. So you can jump right to that step where you do the square root property with the 2 square roots in those problems. In number 7, however, what do you got to do? You got to get what? You've got to get this thing by itself, don't you? Okay. Again, if they're asking you to do the square root property and you got a bracket being squared, you got to get that by itself first. Then you do all the rest of the stuff that we've been doing. Okay? One other note here. You are going to get a perfect square on the next step here. You know what? I'll just get you started. I'll just do the first step. So you're going to get x minus 8 equal to the square root of 25, right? And also x minus 8 equal to the negative square root of 25. What I wanted to point out to you guys is that if you're on this step and you still haven't gotten x by itself, but you got your radicals, okay? If your radicals have a perfect square underneath it, go ahead and figure out the radical right now. Don't wait till the end of the problem, because it'll make it a lot easier to get the x by itself. So since that's a perfect square, I'm just going to say that it's equal to 5 and negative 5. It makes it a lot easier to move the 8 over when the radical's not there anymore, right? Okay. Now, in the other problems we did, the radicals didn't have a perfect square underneath it. Okay, they had 12 underneath it and 63 underneath it in the previous two problems, so we couldn't get rid of the radicals right there. At least not. We could simplify them a little bit, and we could have done that at the we could have simplified it before we had moved the other stuff over in those last two problems, but since it wasn't going to completely go away, that really didn't make things much easier. Okay, so that's why on those previous problems there, I just went ahead and waited till the end to simplify the radical. Okay, so to avoid any mistakes based on things we haven't talked about and things we haven't covered, I would just go ahead and stick to doing that. If it's a perfect square number underneath, like in problem number 3, get rid of the radical by figuring out the radical right away. It makes it easier. But if it's not a perfect square underneath, like 12, just wait till the end, okay, to get the radical simplified. Okay. By the way, one other note here, because I know this is sometimes something that people do, which they shouldn't, so I want to make sure you don't. Can I add the negative 8 and the 2 together right there? No, I cannot. Again, remember the 2, when you simplify a radical and you have a regular term like 2 being multiplied by the radical there, that 2 is a part of the radical term. So that means that you still have this right here is the radical term, and this is a regular term being added to it in between. So you can't combine a regular term and a radical term that are being added or subtracted. Okay, so please do not combine the -8 with the number in front of the radical there for that reason. The 2 is a part of the radical term. Okay? As we talked about in the radical chapter, when you got a regular term being multiplied, not added, but being multiplied by the radical, that thing in front of the radical that's being multiplied by the radical, that is a part of the radical term. Just want to remind you. Okay, so go ahead and try 3, 4, and 7. Okay, hit the play button, and then we'll wrap up this section. Okay, number 3, we already talked about the first couple steps right there. I just need to get the x by itself now. Since this is a linear equation, it's not x squared anymore, it's just x. That means that we move the 8 over on both of these, and we end up with 13 and 3. Notice how the answer does not, it's not like the other problems that we did where the two answers look the same except for a plus or a minus. That doesn't always happen on every single square root property problem, okay? But it does on most of them, okay? So make sure that you don't do one of the answers and then just automatically assume that the other one's -13 because this one's +13, okay? That doesn't always happen, but it almost always happens. So just watch out for that. Okay, number 4. Again, the bracket squared becomes just a bracket, just like we talked about in the last few problems here. We got the 2 square roots. Okay, I am now going to get the x by itself by realizing that, again, this is no different than if you had 5x plus 6 equal to, just make up a random number here again, I'll say 16. Okay, the square root of 75 is no different than 16 in the sense that neither one of those things have a variable in it. So you do the same steps to get the x by itself. You subtract the 6. You then divide out the 5. Okay. And that's exactly what I did here. I subtracted the 6 over. I divided out the 5. Okay. Notice that I put a negative in front of the 6 and a plus in front of the radical like we talked about. Okay. And we ended up with this right here. I kind of skipped the other part here. Let me do that. I'm not sure why I did that. But I'll go and write it in here. On this part, what do we got? We got minus in front of each one here, so this is going to be 5x equal to -6 minus rad 75, like that. And then you divide out the 5, and you can see here that as the 5s cancel on both of these, the two answers we get, again, look exactly the same, except for you got a plus and a minus in the middle of the numerator. So we can condense it down to this right here. I actually did it a little bit out of order here. I'm not sure why I did that. But that's okay. You could do that. You could condense it and then simplify the radical after that. There's nothing wrong with that. It's just that the last 2 steps, we've always done the simplifying of the radical first and then the condensing down into the plus or minus, but you really could do it in the opposite order. That is okay. So I condensed it down with the plus or minus first, and then I simplified the radical. Perfectly fine. The answer should come out the same each time. Okay? All right. Number 7. In number 7, we need to move over the what? Let me get that out of the way there. We need to, just like we've been talking about, if you need to get the bracket squared by itself, you pretend like it's m, okay? And then you do the same steps that you would do over here for 3m minus 24. That means to move over the 24 and then divide out the 3 right here, right? Okay, you get m equal to 8. In the same way, you move over the 24 and divide out the 3, exactly the same steps again. You end up getting the bracket squared equal to 8, just like you got the m equal to 8. Okay, now that I've got the bracket squared by itself with no variable on the other side, I do my double square root thing. Okay. And so I've got that here, but I still need to get the variable by itself, right? That means that, again, just like I said, the radical, because it has no variable in it, it's no different than if you had just a random constant number like 5 there. How would I get the x by itself if it had been a 5 instead of a radical 8? You would just add the 2 over to the other side, wouldn't you? So therefore, that's the correct step, to add the 2 over to the other side. Okay, and then just like we've been talking about, these are not like terms, so you got to keep them separated by either a plus or a minus. Plus here because the rad 8 has to have a positive in front of it. Minus here because the rad 8's got to have a negative in front of it. Okay, we then simplify our radical. Okay, again, I did the plus or minus first. Like I said in the last problem, it doesn't matter which one you do first. Okay, I put the plus and minus in there first, then I simplified the radical. Either way, you end up with the same answer. 2 plus or minus 2 rad 2. Okay, you don't need to circle the 2 rad 2 right there. Just circle the whole thing. All right. 2 plus or minus 2 rad 2. So that is a square root property. When do we do the square root property? Well, first of all, if the directions tell you you have to use it, then you do need to use it. But otherwise, because there will be times in the future when you will be able to choose which method you want to use as well. So the main purpose of the square root property is when you have either a variable being squared or a bracket being squared, and when you get the variable squared or the bracket squared by itself, you don't have a variable on the other side. If you're able to do that, then the square root property is possible. You can use it. Okay. And of course, whenever I give you a problem that says that you have to use the square root property, that will be possible. I wouldn't trick you like that, of course. You would be able to do it. Okay, you would be able to use the square root property. So that concludes section 10.1. We have 2 more methods still to learn in section 10.2 and 10.3. Those are coming up in the next 2 videos. But in the meantime, you have a good day. You take care, and let me know if you have any questions about this.